students, in this video we are going to explain about a project titled House Price Advanced Regression Technique. Our project ventures into the dynamic realm of data-driven real estate prediction, employing the state-of-art algorithms such as random forest and AdaBoost. The primary goal is to revolutionize the house price estimation by leveraging the advanced regression techniques, utilizing an extensive dataset encompassing the diverse property features including the area, location, and amenities. We harness random forest to construct a robust ensemble of the decision tree for accurate prediction. Furthermore, we explore AdaBoost's potential to enhance the predictive performance. This innovative approach aims to empower the homeowners, real estate professionals, and investors with reliable house price predictions, enabling the well-informed decision in the ever-changing real estate market. Embark on this journey with us as we uncover the immense potential of the machine learning in predicting the house price and reshaping the property valuation practices. The project aim is to create a precise and dependable house price prediction model utilizing the random forest and AdaBoost algorithm. Leveraging a comprehensive data set with diverse property features, the objective is to construct an ensemble of the decision tree through random forest, effectively capturing the intricate relationship within the data. Additionally, we seek to improve the model predictive capability by exploring the AdaBoost, which enhances the prediction of the weaker learners. Ultimately, our goal is to furnish a robust tool for estimating the house price, empowering the homeowners, real estate professionals, and investors to make well-informed decisions in the ever-evolving real estate market. These are the basic requirements that are needed to build this project. Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, necessary Python libraries such as Pandas, NumPy, sklearn are imported. These libraries are the fundamental for the data manipulation, numerical computation, and implementing the machine learning algorithms, making the data processing efficient and enabling seamless model development. And the second one is importing the dataset. The dataset contains various features of properties such as area, location, and amenities and is loaded into the project. This dataset serves as a basis for training the house price prediction model. And the third one is data visualization. Data visualization techniques are applied to create insightful visual representation of the dataset. Through plots, charts, and graph patterns and the relationship between the features are revealed, helping the researchers and the stakeholders to gain a better understanding of the data distribution and correlation. Fourth one is splitting the dataset. To evaluate the performance of the predictive model, the dataset is divided into the two subsets, the training set and the testing set. The training set is used to train the model, while the testing set is used to assess the model, generalization, and predictive capabilities. And the fifth one is building the model. The project employs two advanced regression techniques that are random forest and XGBoost to construct the house price prediction model. The first one is random forest. It is an advanced ensemble learning technique used for both the classification and the regression tasks. It operates by constructing the multiple decision trees during the training phase and then combining their prediction to produce the more robust and accurate final output. Each decision tree in the forest is trained on a random subset of the data and the features are randomly selected for each split. Ensuring the diversity among the trees, the final prediction is determined through a majority vote or averaging of the individual tree predictions. Random forest is known for its ability to handle the high-dimensional data, non-linear relationship, and complex features interaction, making it a popular choice for the various machine learning problems. And the second one is XGBoost, stands for Extreme gradient boosting is an optimized gradient boosting algorithm designed to improve the performance of the traditional gradient boosting method. It builds multiple decision trees sequentially, with each tree correcting the errors of its predecessor. XGBoost employs a unique regularization term in the objective function to control model complexity and prevent overfitting. This algorithm excels in capturing the complex pattern and non-linear relationship in the data. It also supports parallel processing and efficient memory usage, making it highly scalable for large data sets. XGBoost has gained the popularity in the various machine learning competitions and real-world application due to its exponential performance and the robustness. And the sixth step is training the model. The random forest and XGBoost models are trained on the training data set, allowing them to learn from the patterns and the relationship between the various features and the corresponding house prices. And the seventh step is user gives input. To make the house price prediction accessible to the user, a user-friendly web application is developed using the Flask framework. This application enables the user to input the specific property details such as area, location, and amenities for personalized house price prediction. And the eighth one is the given input is pre-processed for prediction. Before making prediction, the user input is pre-processed using the same techniques applied during the training phase. This ensures consistency and prepares the user data for the predictive model input format. And the ninth step is trained model is used for prediction. The pre-processed user input is fed into the trained random forest and XGBoost model. These models utilize the learned patterns from the training data to predict the house price based on the provided property details. And the last one is final outcome is displayed. The predicted house price for the user input is displayed in the web application. This valuable outcome assists the owners, real estate professionals, and investors in making informed decisions by providing the reliable and accurate prediction for the real estate market. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of different files within it. The static folder containing of the CSS, JavaScript, assets, vendor files within it. And the template folder containing of the HTML documents within it. This contains of home, index, notebook, result, sign-in and sign-up pages. And the app is an py file contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the housing is the dataset that we used in this project, and the notebook is an IPYNB file which contains the combination of the code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the model.pickle file will be used to store the algorithm's information, and it will be performed and used at the time of the execution of the project to perform the certain tasks such as of making the prediction on the new data. And the signup.db is the file appears to be the database file used to store the user information. And to execute the project, we build the Flask framework as a front-end. And the total code available in the IPYNB file as the combination of code, graph, and output all in one place. For the execution of the project, first we need to copy this code folder address and open the Anaconda prompt. Here first we need to change the disk location to F because our code folder is presented at disk. Then write a command cd space and paste this code folder address, and by this command the directory will change to the code folder path, and then write a command python space app.py. By using this command, it will execute the Python script and perform a runtime check for any syntax errors or the logical issues, and then click on enter button. After running the app.py file, the Flask framework will host the application locally at the default address. Like this, we need to copy this local link and paste it on any of the web browser. I would prefer to use the Google Chrome, and then click on enter button. Here we get an page consists of title of the project, sign in and sign up buttons, and click on the sign up button. It redirected to the sign up page where it contains the details like this. We need to fill these details for registering the account, but my account is already generated, that's why I'm using the sign in page, and it redirected to the sign in page contains of the username and password, and my username and password is of admin. I'm entering the details and then click on submit button. Here it redirected to the index page containing of some input details we need to be filled, and area is of 1300, that is at 1300, and the number of bedrooms is of 3, and the number of bathrooms is of 3, and the stories of 1, and the main road, if you want to take the main road S or it's mean 1, no it's means of 0, and I need S, and the guest room 2S, and the basement is of 0, and the hot water heating is as 1, and the air conditioning as is 1, and the parking as is 1, and preferia and as is 1, and the furnishing, it's of furnished means 0, semi-furnished means 1, and I want fully furnished, that's why I'm 0, and then click on the submit button. Here the predicted result of the house price as our input details is of like this, and to try by using the try again button, it will back to the redirected page as of index file, and here we can re-enter the details of 3500, area bedroom of 1, 2, and bathroom of 2, and stories of 2, and the main road no with 0, and the guest room with 0, and the basement is of 0, and the hot water heating is also with 0, and air conditioning with 0, and the parking is of 0, and the preferred area is of 2, and the furnishing is of 1, and then click on the submit button. Here the result of this will be of price of like this. In this way we can predict the price of the house by giving some input details. And here this is the comparison graph where x-axis represents the score of the accuracy of each algorithm, where y-axis represents the algorithms we used in this project. And in conclusion, our project has successfully achieved its objective of developing a highly accurate and reliable house price prediction model through the utilization of random forest and AdaBoost algorithms. We have created an ensemble of the decision trees that effectively capture the complex relationship within the dataset. The predictive performance of the model has been significantly enhanced by leveraging the strength of both algorithms. As a result, our project offers a powerful and valuable tool for estimating the house price with precision and confidence. This advanced regression approach empowers the homeowners, real estate professionals, and investors to make informed decisions in the ever-evolving real estate market, ultimately contributing to more informed and successful property transactions.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.